بسم الله الرحمن الرحيم. Electrical safety. First of all, we're going to discuss main supply, skin impedance, and earth. As we can see from the figure, there's a power station of around 11,000 volt, which is transferred to three phases wires of 250 volt by transformer. This is at the substation where the wires goes to the hospital through the socket. The wires are made of what we call the active one and the neutral. The neutral one is being connected to earth. You see, so this is the three wires entering the hospital. We can see a figure where there is damage in the active wire, and the person is touching this active wire. The electricity, of course, can go through him and through earth, completing the circuit. And the outcome is according to the resistance of his body and the footwear. So it may be around 1 millivolt. Whenever I divide the voltage over the resistance, we can create a 1 millivolt. So he will not feel apart from tingling, because we must consider that the skin and the tissue are ignored regarding the impedance. But if the current is high enough, reaching around 24 milliampere, due to the low footwear resistance and the body, we can divide the 240 over less resistance, which is 10 kilo ohm. This will create a figure of 24 milliampere, which is capable to induce a ventricular fibrillation. So this is another figure also showing the personnel carrying an equipment as he is touching the pipe. This pipe is touching a pool of saline. Of course, the saline is a good conductor of electricity, and there is a fault, as you can see, from the earthing wire. So the electricity goes through him, reaching the earth through the pipe, and the circuit is being completed, and he can be affected. So if this current reaches 24 milliampere, it can induce ventricular fibrillation. Of course, there are factors that increase the incidence. If the hand is wet, this is why you ought to wear gloves whenever we carry electrical wires. And of course, the surface area, if we are touching with a large surface area, this increases the incidence. And if there is any cannulas in our hands, suppose when the patient, he's liable. And if the current reaches the T wave of the ECG, he's liable to develop ventricular fibrillation. Also, the frequency, as we know, the frequency of the current is 50 hertz in England and 6 in America. Is an important item to create ventricular fibrillation. Not as the one used in DIATHERMY, where the frequency can reach up to 1 kilohertz. So this high frequency will not induce ventricular fibrillation. Of course, patients having myocardial disease and the hysterismia can be affected by a lower current. How can we protect against electrical shock? Of course, as we said before, I'm sorry, I forgot to tell you that the footwear to increase the resistance ought to be 75 kilo ohm up to 10 mega ohm when new. You see, you must put it when new. These items must be considered whenever I want to protect the person from being electrocuted. Of course, this high resistance enough to admit the dissipated static electricity, but it will cause a good resistance for the electrical quotient not to happen to the person. So we have three classes of equipments according to the International Electrotechnical Commission Standard 601, where they divided into three equipment. The first equipment, which is an earthed equipment. Suppose this is an earthed equipment, as we can see, there is a chassis outwards, which is the protective layer, and we have an electric component inside. Suppose a shortage occurs. What's the meaning of that? That the electrical power is being affected and reaching the outer surface. So whenever I touch the outer surface, I can be affected by electricity. But this system has what we call fuses inside and fuses outside. this fuses whenever this electricity or the fault occurs. It creates heat. This heat melts the wire in these fuses and cuts off the electricity. This is how we can save. But this equipment needs to be airsed. The second type of equipments, we, instead of using one layer, we double these layers, the protective layers, or we reinforce it. This is the way in which whatever you touch, you will not be affected. The second one, the third type is called the internally powered equipment, where we use batteries. Batteries, the difference between batteries and the alternating current, that the batteries are going from the negative to the positive pole, but electricity or the alternating current is electrons going through the active, returning by the neutral. So the both are the same potential. The neutral one is called return poles. So this is the third type of equipment. It will avoid the hazard of the alternating current, but if we have a low resistance of ohms, definitely it will create an electrical affection. Shock risk with airsed equipment, as we can notice before, though, that's the airsed equipment, which is the type 1 type, class 1 type. If there is a faulty affection of the lines entering the socket, as you can see, the airsed one is being broken, and then the patient is touching the stem of a lamp, as you can see, and this lamp is being airsed, you see. So whenever there's a fault, the electricity must go out. So it goes through the patient and comes out through this airsed, where it completes the circuit. So he's liable to be affected by this fault airsing wire. Of course, we never forget the blanket used in protection against diathermy. It's made of plastic, but also it's metal. So this metal is it creates a low resistance for the current to go whenever there is fault. So it is a source of completing the circuit where the patient can be affected. So must put it in consideration. Also, the electrodes of the ECG can be a source of the electricity coming through and causing electrical affection. Diathermy risk, as we know that diathermy works at a frequency of around 1 megahertz, which is a frequency not inducing ventricular fibrillation, but can induce burn, and this is the basis of coagulation. So we have an active electrode used by the surgeon and a neutral electrode, which is spread all over a large area of the patient. So the current density is very low. You see, this is why we don't get burn unless there is a fault or the surgeon is using the electrode and there is no connection, or there is a fault in this neutral electrode not touching completely the patient. So the current density will increase, and this will induce burns at the parts of the patient, especially, of course, the parts where they have a low density, as the fingernails. You see, the fingers. I'm sorry. So in the past equipment, we used to have what we called isolating capacitor. The capacitor has the capability to transfer high frequency current that is present diathermy and not transferring the 50 hertz current of the alternating current. So we are creating an alternative pathway. So this is a method to avoid electric caution by using what we call the isolating capacitor. See, this is the capacitor which is airsed, but this is a capacitor. This is, I'm sorry, the equipment which is airsed with no capacitor. This is the capacitor which creates an alternative way, thus protecting the hazards of electric caution. But we must assure that the neutral plate is being placed in a proper situation. Isolated patient circuit, is a system nowadays by using an isolating transformer. And this isolating transformer, not as the normal transformer, it is completely made of two circuits. The one circuit which has electricity, which is airsed, and the other one is the component of monitor reaching the patient is not earthed. It has coils, but the electricity in the primary cell is being transmitted to the other cell by electromechanical forces. So there is no chance for the the secondary cell to be affected by electric quotient because it's not earthed. So this is what we call the isolating circuit. In the past, they used to use what we call the indifferent electrode in ECG to decrease the incidence of interference. This one was attached to the case of the monitor. So this case is being earthed. So whenever there is a fault, the patient can be affected because he is being earthed through the monitor. Nowadays, of course, there is an isolation, complete separation between the component by reaching the patient and the electrical component. So as we can see, the efferent electrode is not touching the case of the electrical component. This is one of the methods to avoid the electrical component. Microshock is an item means that the very minimum current up to 100 microampere can induce ventricular fibrillation. Not as the one we noticed before, the 24 milliampere, which goes from the head to the foot, passing by the heart. First of all, of course, the current, whenever is less, it causes tingling, and then it causes contraction of the muscles, especially the flexors. The flexors are more prone than the extensors, so that we catch, whenever we are electric coated, we catch the electricity more. This current, which is very little amount, can be affected. How can it reach the patient? Of course, it can reach by faulty apparatus reaching the heart, as the catheters, cardiac catheter, the thermometers, which is behind the electrical thermometer, which are being introduced into the esophagus, which is behind the heart, and the pacemakers. All these are faulty catheters reaching to the heart. It reaches the heart and touches the heart in a very small area. So the density of the current is very minimal to induce ventricular fibrillation. So we have a nice figure, as we can see, an anesthetist touching a monitor. This monitor is being earthed. The patient is sleeping on the table, and then there is a fault, as we can see, and the anesthetist is touching the patient. So there is a catheter reaching the heart, and there is the fault. So electricity can be completed through the patient by the anesthetist. You see. And the patient can be affected in inducing ventricular fibrillation. So we must be considering this whenever we work in the cardiac theater, that whenever there is a fault, we can be a source of creating. Of course, we are not affected. Why? Because the current, which is very little, 150 microampere, is very little. It will not be noticed by the anesthetist, but the heart will be noting that and will create ventricular fibrillation. So whenever I am asked to confirm apparatus reaching the operative theater, we must be assured that this apparatus will not cause a leakage current. What's the meaning of leakage current? As we know, any apparatus, any electrical equipment is made of capacitors and rectifiers. A rectifier is a component which changes an alternating current to a direct current, which is present in the defibrillator. So we have a capacitor, resistors, and inductors. All these components are present in any electrical circuit. These components can create what we call resistive capacitor leakage current, additional current to the circuit. So it can be noticed by creating a difference between the active electrode and the neutral electrode. If we notice the difference is not, there is a difference, of course, both of them ought to be equal. But if there is a difference, that means there is a leakage current. So this leakage current can be a trouble maker in such circumstances. So whenever I'm asked to confirm apparatus reaching the theater, I ought to have a notice about what's the meaning of cardiac floating apparatus. It's a apparatus a floating apparatus, as we said before, we must have a leakage current not less than 50 microampere, because this, in comparison to the 150 microampere that may induce ventricular fibrillation. Whenever have and monitor use outside the cardiac theater, we have what we call the B type and the B floating type. We ought to have a leakage current not more than 500 microampere. The cardiac pacemaker, we have two types of cardiac pacemaker. We have what we call the temporary. The temporary is being introduced as a CVP, and the wire is reaching the heart, and then this wire is being based or inducing a potential in it. This potential is around under 1 volt for 1 millisecond to induce the process of contraction of the heart whenever we have suppose a cardiac heart block. And the other one is made of a battery, and we must have a cardiac surgery, so that we must use an X-ray and equipment to guard against arrhythmia. This electrode, of course, reach the ventricle or the atrial accordingly, and we induce, of course, the pacing volt for a couple of seconds to induce the contraction of the heart. So this electrode reaching the heart has to function apart from pacing. It also has a demand function. What's the meaning of demand function? It continues causing a contraction and inducing electrical stimulation as long as the cardiac heart is within normal range. But if the heart is asked to work, suppose the heart begins to work, it senses this and stops working. So this is the point regarding the demand type. There are many circumstances that induces this deceiving as if it is a cardiac reach. I'm sorry, as if it is coming from the cardiac muscles. So the device is going to be deceived. Suppose I have the DIATHERMY, we have electromechanical. All these are creating electromagnetic waves, which will deceive the electrode, thinking that it is coming from the heart. So it stops. So the patient will feel dizziness at this point. This is why at that time we ought to change this demand to fixed type. What's the meaning of fixed type? It induces a rate irrespective of the changes around it. You see, this is the meaning of fixed. And sometimes any patient with a pacemaker is admitted to operative theater. He goes to the cardiac specialist, where he changes this demand type of fixed type, which is not affected by DIATHERMY. So, of course, whenever I have a pacemaker, ought to have to use what we have, what we call the bipolar, not the monopolar, so that it will not induce a deceiving electromagnetic wave for this electrode, because this electrode acts at that time as an aerial. It receives electromechanical waves. Of course, conducting fluids are a good source of electrical transmission. Must be care whenever have a monitor not to splash the water around it. Of course, it will conduct electricity, and it will decompose the gases into an inflammable gases. You see, to hydrogen oxide. So these are inflammable gases. Power of failure, of course, we must have a source of battery in case of failure. Of course, we have most of the equipments are using what we call the microprocessor. A microprocessor is integrated electronic circuit performing data storage, computing, and control function to give a rate. It has a memory. So this memory affection can be affected by electrical equipments around, and will induce a failure in the equipment. So it may induce much current. And this is the picture of the capacitor, as we can see. Two conductors are separated by insulator or dielectric. This is the picture showing the station where we have a transformer shifting to 3 lines, each lines, the 3 lines are attached to what we call the star point, which is earthed, and we have 240 volt from these 3 phases, and this is how a floating circuit works. We have an isolated transformer, as we can see. A transformer are separated. It's one of this transformer, which is earthed, is which has the electrical component completely separated from the other circuit. This electrical circuit creates an electromagnetic waves, which is transmitted to the other coil. You see, this coils, of course, has degrees, and the difference between both of them, first of all, denotes whether they are building up or building down volts. So we have a transformer which increases the volt or decreases the volt according to the difference between the number of windings of the coils. You see, so this circuit is completely separated from this circuit. This circuit has been earthed, but this circuit is not earthed. It's controlled by a special monitor. This is what we call the floating circuit, and this is items that are present behind any electric apparatus to notice what's the meaning of P floating or C floating and non floating circuit. And this is a nice figure showing a train. A train goes through a railway. This railway creates an electricity, but this electricity must be completed through the earthing. So as we can see, the earthing by this part of the metro or whatever touching this upwards wire, the birds standing are not fried. Why they are not fried? Because they are not completing the circuit. If you touch the bird, you will complete the circuit because you are touching the ground. You see, so this is why they are not fried. I hope that I accomplished this topic. Of course, I was based on the main book, and I got some pictures and other sources from other internet source. Wassalamu alaikum wa rahmatullahi wa barakatuh.